All right, good morning, everybody. I'm Jeremy Pickens. Work for Auburn University in the horticulture department. I'm stationed down in Mobile, and I serve as the nursery and greenhouse specialist for the state. And extension in the Alabama Nursery and Landscape Association has been doing this monthly webinar series for a few months now. And if you want to see some of the other webinars, you can get on to the ANLA YouTube page and see all that's already been presented there. And this one will be posted probably within a few days. But today I'm going to talk about monitoring container nutrition in woody shrubs. And this is kind of timely because at least down here on the Gulf Coast, and we've been having some terrible problems with heat and lack of rain, and seeing some really high fertility levels in some of the containers out there due to those issues. We're not getting the normal flushing we get with our afternoon showers. And so I thought this would be kind of a timely presentation. And like I said, not only has the air temperature been real warm, so has those containers. And that's really important when we're talking about our control release fertilizer, because they release based on temperature. And our average soil temperature has been very high pretty much all summer. And even our night temperatures, ambient air temperatures, have been pretty warm. And so we're not losing as much heat from those containers as we normally would in our typical summers. So like I said earlier, we use control release fertilizers, and these are great products, but even these can have some problems depending on the temperature and the length of time it's exposed to high temperatures. But we can monitor these temperatures through a couple of different ways. And one way we can monitor the nutrition. One way we can do it is through monitoring the EC. And so what is EC? That stands for electrical conductivity. So if you think of fertilizers as salts, the more salts you have in a solution, the more conductive it is. So we can measure how conductive that solution is and kind of gauge a fertility level based off of that. We also can monitor our pH in our containers. And I've seen some issues over the last few years here with really low container pH, even as low as 3.8 in some cases. And that's because some of our wells, especially their shallow water wells, have are kind of acidic. And in certain situations, you can get your pH can just plummet. And so it's nice to be able to monitor both of these, so you know what your fertility level is in your container, and then what your pH is, and whether you need to make adjustments based off that. So you can see this is just an example of the lime, and most folks have no idea what the pH in their container is. And you can see here, now we have that acidic well water here at the station, and you see that blue line is a 6-pound rate, which is kind of common. I recommend, at least down here, going 8 to 10 pounds. But you can see after 25 weeks here at the station, we dropped down to 3.5. And some crops can handle that. Some hollies won't miss a beat. Something like a loropetalum, though, you're going to start seeing some issues. So it's important to be able to monitor that and know what you've got, especially if you're troubleshooting. But it's even more useful if you can monitor over time and kind of keep up with a trend, kind of like you see here in this graph. This is where someone has monitored both their EC, or their nutrient levels in their container, and the pH over time. And that just kind of helps you with management decisions. So the primary way that this is accomplished is through the pour-through procedure. That allows you to monitor both pH and EC. And I'm going to kind of go through the steps with that. But if you want to read about it on your own, a really great publication is this one here, the pour-through extraction procedure. This is from NC State. And so if you want to find this, you can find it very easily by just Googling NCSU pour-through and nursery, and it should be the top hit on that Google search. So the concept behind this is we're wanting to test that water in the root zone for pH and EC. And we're going to extract that water by pushing the water in that container out by pouring more water on top of it. And so that water that's pushed out of the container, that's what we call a leachate, and that's what we're going to test. So that kind of provides us a representation of nutritional status in that container. So step one, if you want to do this procedure, you need to bring the plant to container capacity, and that's a little difficult. So most people, what they'll do is they'll just simulate a normal irrigation event for that crop, just your standard, what you would normally do on a typical day. So you're going to do that, then you're going to wait about 30 minutes to an hour. And during that time, what's going to happen is that water is going to kind of equilibrate with the nutrients. So the nutrients are going to get passed back and forth between the existing soil moisture and the substrate and the fertilizer. And so that's going to, you know, by allowing it to wait, it lets it equilibrate, and that gives you a better representation of what's going on in that container. So you've watered your containers, you've waited an hour. The next step you're going to do is you're going to place it on some sort of a catch pan. A lot of people use these little saucers you see here on the right, those clear saucers you see for house plants. If you use one of these, a lot of times they're flat bottom, so you need to elevate that pot above that saucer, because there's a lot of fertilizer salts that accumulate and dry on the bottom of that container. And if it dissolves in that water, it's going to give you a false reading. So you need to elevate it. Some people use PVC rings. You can use Coke caps, anything to keep the container from touching the bottom of that saucer. For the last 5 years, I've been using these disposable paint pans, and we reuse them, and we've got stacks of them. They hold up as long as you don't leave them out in the sun, but they have sort of a pitch to them, and they elevate the container off that flat surface. And for us, they've been really great to use, and they last a long time. And you can get those in most of your box stores. So that's your catch pan. This is what's going to catch the leachate coming out of that container. The next step is you want to pour a specific volume of water evenly across the top of that container. And your goal is to get 1.5 ounces to 1.7 ounces of leached water out of that container. And that's what you're going to test. So if you pour too much water over the top, you could get more water than you need and dilute that leachate. Or if you pour too little, you may not get enough, and it may be too concentrated. So you're shooting for around 1.5 ounces to come out, and it takes a little practice. And this is you want to pour that water evenly across the top of that container. You don't want to pour it just in one spot. That way that water is pushing evenly down with gravity down that water out of the bottom of the container. So what kind of water to use? A lot of people use distilled water. A lot of folks use the source water irrigation, and that's what we do. We just use our source water irrigation because it's easy to get, for one thing. And for me, it just gives you a little bit better representation of what's going on in the event. In the event that you did get a little bit of dilution, your pH should still be around the same. So how much water to pour? In that same guide I showed you earlier, there's a little chart in there that gives you kind of an idea. And this takes some practice. You kind of got to get a feel for it. It depends on the age of the crop, whether that potting mix has peat in it or not, the size of the container. But this is kind of just a little guide to kind of give you an idea of how much to pour. Typically, for a gallon container, I'm pouring anywhere from 100 to 150 milliliters, or about 4 ounces. And for a 3 gallon, I'm pouring about 350 mils, or about 12 ounces. And again, the idea is to get about 1.7 mils, 1.5 to 1.7 ounces out of the bottom of that container. You know, another option, if you are pressed for time, is, well, first off, you should let that container sit for about 30 minutes to drip. You know, but if you don't have enough time for that, you can tip the container, and that'll speed things up a little bit. If you do it this method, you just need to be consistent and do it this way every time. But that is considerably faster to do it this way if you're in a hurry. So after you've collected that leachate, you're going to measure, and you're going to measure it with a pH and EC meter, or you might have a combo meter. And there's a lot of options out there, and wide range in prices. You can get digital meters. You see this old analog looking thing that looks like it's from the Apollo 13 era. This agrimeter, these are great. They're bulletproof. They last a long time. You can beat them up in your truck. As long as you keep the pH sensor filled with a storage solution, they'll last a long time. And that's one that I like to recommend to growers. But there's a lot of options out there for pH and EC meters. And if you want some recommendations, you can get up with me and I'll tell you some of the ones that I've had good luck with. So the next step is you want to record that data. So, you know, you want to know the date, the crop, your pH, your EC. You can put that in a notebook, a spreadsheet. Some people just write it on a piece of scratch paper and take a picture of it, because I know you're in a hurry and you don't have a lot of time for this. Just any way you can, keep a record of that, because it's nice to be able to go back in time and see what's going on. So as far as some recommendations on the ranges, for most of our crops, at least with woody shrubs, we're looking from 5.5 to 6.5, or really about 6.3 would be better for our pH. And then our electrical conductivity, anywhere from 0.5 to 1.5. If you get up to a 2, that might be high. Now, this is for woody shrubs. If you're in floriculture crops, you got a completely different range here. They can handle a lot more. But with controlled release fertilizer and woody shrubs, 0.5 to 1.5 is a good number. Now, when you get a reading, you're going to see all kinds of different units potentially on there. It could be any of these ones listed in this beautiful bullet point, like micromoles or millisiemens or microsiemens. Just ignore that unit. If you get a very large number, divide by 1,000. For example, if your reading is 300 for your EC, just divide by 1,000. That's going to be a 0.3. And so here's an example of here. If you got 1,500 micromoles divided by 1,000, that's going to be a 1.5. And that's just a little bit more standard for people if you're communicating with either an extension specialist or other growers. That's just a little bit more universal than those larger numbers. An alternative to doing the pour through method is there's some direct stick EC meters out there now. Some of them are pretty good. This is one I've been playing around with. It's the Blue Lab pulse meter. It's relatively inexpensive. It's relative. It's about $300. And what's nice about this is it does pH. It does not do pH. It does EC, soil moisture, and temperature. And it does a pretty good job with soil moisture and temperature. And the EC, we haven't really, we don't really know like how that compares to normal pour through. We need to do a little test on that. So you may need to build your own scale. So if you get a 0.5 with a pour through, it may not be the same as a 0.5 on this meter, but you just kind of have to build your own scale. But it's nice because this Bluetooth's right to your phone, and you can store that information on there or export it to Excel. You can add notes to it, so you can put your crop, and keeps up with the date and time and all that information for you. I think this has a place, especially with larger containers, where it's really difficult to put a catch pan under a 15-gallon pot and collect that leachate. But so far, when I've been using this, it's been a pretty neat tool to use, and I see a lot of useful applications with it. There's also some in-pot sensors out right now, especially for soil moisture, and some of these also will measure the electrical conductivity of the substrate. And these are pretty good. Again, I don't know how the scale compares to a normal pour through scale, so you'd have to kind of get a feel for it over time. But what's nice is these can get loaded directly to the cloud, and you can look at it anytime you want on your cell phone or your computer. And they're fairly accurate. It just it takes some getting used to, especially with the soil moisture. You kind of have to play with them a while to kind of understand how to make management decisions with that. But this might also have applications in larger containers where it would be difficult to do pour through. So if you have that data, what do you look for, or what are you going to do with it? So if you're looking for trends, you need to be taking data over time, or you might be using it to troubleshoot. If you see that your EC is bottomed out, then you may need to add more fertilizer or not, depending on what time of year it is in the crop and your own management style. If your EC is too high, that means you may need to flush a little bit. And again, it takes some experience to kind of get a feel for what those numbers mean. And if your pH is bottomed out, then you may need to top dress with some lime or drench with a flowable lime source. That's easier said than done. It's really difficult to get your pH back up if it's bottomed out. But if you have a problem with that, get up with me, and I have some recommendations that we've seen work pretty well. So I'll give you an example of how we've used this procedure to just troubleshoot. We had a nursery that was growing some New Guinea impatiens, and every day they would come in, and there would be 4 or 5 of them all in the same area, dead or dying, just completely wilted by the end of the day. So they would water in the morning, it'd be okay. Then by the end of the day, it was wilted. And they checked the EC, and it was maxed out on the meter, but they didn't think anything of it because it could handle a pretty high EC. So we went out there, we said, well, let's see what happens if you dilute it. So we diluted it by a factor of 4, and we finally got a normal EC reading. And I asked, does your fertilizer injector click if you ever walk by when it's not pressurized? And they said, yes. And come to find out, that injector was still feeding concentrated nutrient in that line. And so you were getting a super concentration of liquid fertilizer. And those first 4 plants every day were just getting nuked, but without an EC, reading, we would have never known that was going on. So there's a lot of applications to troubleshoot. You can test your fertilizer, levels in there to know if you need to add fertilizer or you need to flush. Otherwise, if you're waiting for just crop color as an indicator, you're wasting time. Then you got to catch back up after you've brought those plants back up to a good level. So it's nice to be able to do this and keep up with your container nutrition. And some considerations, if you're doing trends, you might want to test. I know it's labor intensive, but you might want to test every 3 to 4 weeks a crop. And you definitely want to test more than 1 plant per crop, because there can be a lot of variation between plants in the same block. That's can be due to your fertilizer applicators, or it could be due to the distribution uniformity of your irrigation. A lot of these older systems aren't very uniform. And so you may get different EC readings pot to pot just based on how that water's falling. You definitely want to avoid doing the procedure after a heavy rain. If you get a 2-inch thunderstorm that comes through, your EC is going to be bottomed out. So you need to wait some time for those for that fertilizer to release again to get a more accurate reading of your fertility levels. You also want to buy a quality meter. I mean, there's some really cheap ones out there you can get on Amazon for $20, but a lot of those, they don't last. And you want to take care of it. Read the directions. You want to store that probe correctly, especially the pH sensor. They're very sensitive to drying out, so they have storage solution. You put it in, and then you want to calibrate it regularly. It doesn't take long for most meters to calibrate. I calibrate every time I use it, just to make sure I'm getting the correct reading. Also, depending on your location, not so much an issue down here in South Alabama, but in North Alabama, where you have a lot more hardness in your water, you might have a high EC reading of just your normal irrigation water. And so what you can do in that case is subtract your irrigation water EC from that leachate EC to give you a more accurate representation of what that nutritional status is in that crop. So that's just kind of a quick overview of that pour-through method and how to monitor your container nutrition. And if you have any questions about this, I can answer those now. And if you want to dive into it deeper, please give me a call. I'll be happy to walk you through it. And if you're nearby, I'm glad to come out and show you how to do it. So with that, I'll take any questions.
Pickens, this is Marcus. How you doing?
Hey, Marcus, how you doing?
Doing good. I really enjoyed your presentation. Very, very good information. I was just wondering, where can I purchase some good storage solutions from? Because I need to I need to start storing my instruments just a little bit better than what I'm doing.
Well, there's a lot of outlets out there. You can get it on Amazon. It may be that the meter has a specific storage solution. Some of them just use a pH 4 buffer, but I would read the directions and see. And a lot of times you can get them on Amazon or some of the laboratory suppliers like VWR or Fisher.
Yes.
But if it's dried out, it may need to be replaced. So you can try to calibrate it and make sure it's still working.
Appreciate it. I really enjoyed the presentation. Thank you.
Thanks, Marcus.
Y'all don't all jump at once. Well, Jeremy, that must mean that it was a pretty thorough explanation of everything. We had some good video examples in there, so maybe that's why there are no questions.
Must be. That's great. Well, all right. Well, thanks, everybody. I appreciate your time today.